Good afternoon, everyone, and thanks for joining us for this session. My name is Bethany, and I'll be facilitating alongside Jamie for the session today. I'm joining from Belgium today, where I'm studying my master's in soils and global change, and Jamie is joining from Oxford, where he's studying biology. We're both members of a group or a collective called RE-PEAT, and we're a youth-led collective that's working to bring about the peatland paradigm shift, which essentially we take to mean a shift in how we imagine, think about, and use peatlands. And we've been going for about 2 years now, and we organize a lot of events around peatlands. So we organize a Peat Fest every year, which is a 24-hour long online global festival, basically a big celebration of peatlands. We've also held UK-specific webinar series as well, where we took peatlands as well as a certain other topic, such as forestry or gardening or agriculture, and kind of discussed how those two interact with one another. And so that's kind of just a little bit about RE-PEAT. I won't kind of give too much information about us, just maybe what's good to know is kind of we want to approach peatlands from a very interdisciplinary perspective, so kind of looking at the historical implications of peatlands and the peat-human interactions through time, the lessons we can learn from peatlands, and how that can maybe challenge our dominant ways of thinking at the moment, as well as the biodiversity potential, the carbon sequestration of peatlands, all these different kind of topics and ways that we can look at peatlands. And if you have any more questions about that, or maybe you'll get a sense of kind of what we've been up to as we kind of go through the session as well. And the other thing I wanted to do just before we get started was to, I see people are introducing themselves in the chat. That's nice. Maybe you can also do that. Cool. I also just wanted to give a short explanation about peatlands, just so we kind of go into the session from a shared angle, really. And I know a lot of people maybe know about peatlands already. Maybe some people have heard of them. I guess in the UK, they're a lot around the place, so probably you've come across them even if you don't appreciate that you have. So basically, a peatland is formed when you have waterlogged soils, and as the plants that are growing in these soils fall below, they're unable to fully decompose because of the lack of oxygen that's caused by the waterlogged soil. And so they kind of stay in a partially decomposed state, which means that the carbon that they have with them in life stays with them in these layers of peat. And that's why peat is such a huge carbon store. And now they have a lot of other benefits and kind of offerings as well, from kind of biodiversity, hosting, to flood prevention, water regulation, and all sorts of different wonderful offerings that they give us. And maybe you'll see a few of those as we go through the session as well. But specifically today, we're focusing then on paludiculture, which is the form of agriculture that takes place on peatlands. So with plants that can grow under wet conditions, essentially. And the idea behind paludiculture is that plants can grow and be harvested at the same time that the peat layers continue to build up. So you're kind of having this interaction with the peat that's not damaging the way that it needs to grow as an ecosystem or develop as an ecosystem, but there's also benefits that are coming for farmers or for local communities. And as far as we're aware, this is the first time that this kind of session or session on paludiculture has been held at the Oxford Real Farming Conference, which is really exciting first off. And so we're happy to be kind of starting a conversation around that. And it's also incredibly timely, I think. So, you know, as I mentioned, peatlands are a huge carbon store. So with the ongoing climate crisis, it's incredibly important that we talk about peatlands and explore what role they have, which is an important one, kind of going forward towards a more climate safe or climate just future. There's also a lot of funding happening now in the UK for peatlands, so it's quite an opportune moment for that as well. And I think there's quite a unique moment facing paludiculture, because it's quite an old practice, but then it was forgotten for a while, and now we get to go and look forward again. So that gives us quite a unique chance to assess in what way do we want to pursue paludiculture. How can we do it in a way that has a focus on land justice or climate justice, environmental justice. So we really want to be able to kind of bring that perspective into it as well. We're not experts in paludiculture. We're not currently involved in trials ourselves. we're both kind of studying topics that I think will get us there at some point. So Jamie's particularly interested in sphagnum and I'm doing soil science. So maybe at some point we'll be involved in that. But really what we want to do is get the conversation started, kind of explore the topic just to start with, introduce it, and then see where people run with it. Who maybe people want to take it further, maybe people kind of keep this idea with them, and we're just really excited to see where this can go. And that's kind of the role we see ourselves in at RE-PEAT just in general, is to kind of bring people together into conversation about various topics and explore how different angles of interacting with peatlands can bring us to this peatland paradigm shift, or viewing peatlands in a different way. And so you'll also be hearing today from a couple of people, Ralph and Kate, who've recorded talks, which will tell you a bit more about the trials and the work that they're doing on the ground with paludiculture. So we'll be sharing those as we get going. And we'll start with just a video that we made about some paludiculture plants. And this was from a session from the UK anthology series we hosted, which was looking at peatlands and agriculture. So it's just, Jamie will just share a screen in a second. It's just a short video to give a little bit of an insight to what plants can grow on peatlands and kind of the variations that maybe you don't expect that can grow under these kind of wet conditions. So go ahead, Jamie.
Thanks, Bethany. So yeah, I'll go ahead and share my screen so we can watch this video.
Paludiculture is the productive land use of wet and rewetted peatlands that preserves the peat soil and thereby minimises CO2 emissions and subsidence. Here are 10 paludiculture plants that you need to know. Alder. Alder trees form a symbiotic relationship with a nitrogen-fixing bacteria. Their wood can be used for all sorts of carpentry applications. Bog myrtle. Another amazing nitrogen-fixing plant that's a natural insect repellent and can be used to flavour beer. Sedges. There are loads of species of sedge that are specialised to peatlands. Although we might not eat them, they can be a good source of fodder for cattle. Water mint. Mint can be cultivated on peatlands for use in tea. Its flowers are also great for a range of pollinators. Reed. Common reed was traditionally used for thatching roofs. You can also compress reed into insulation blocks. In China, there's a high demand for reed to make paper. Cattail. Cattail, also known as bulrush, has loads of big air spaces in its stems, which help it transport oxygen around its body. These air spaces make it great as a material for insulation bricks. Wild rice. Wild rice is similar to the domesticated variety that most of us know. It's been a vital food plant for First Nations and Indigenous people in North America for thousands of years, for whom it's also of great cultural and historical importance. In the UK, wild rice is being trialled for cultivation on peatlands. Cranberry. Whether you like your cranberries juiced, dried, covered in chocolate or with a splash of vodka, we need boggy conditions to grow them in. Sundew. The carnivorous sundew is one of our favourite peat plants, with its bright alien tentacles and delicate white flowers hovering above. Well, it also contains several pharmaceutically important compounds. These compounds have anti-inflammatory and antibacterial properties and help treat coughs. And last but not least, sphagnum, aka peat moss. Sphagnum isn't edible itself, but rather you can grow edible plants in sphagnum. Basically, instead of using peat to grow fruit and veg in greenhouses, you use the plant that peat is made of. Growing sphagnum for compost means farmers can earn money from re-wet peatlands and at the same time divert demand from peat mining.
Yeah, so that was a video we made as a part of a kind of series of animations that we've kind of done with webinars on like peatlands in the UK, which you can see on our YouTube channel. And you know, that was 10 plants, which might seem like a lot, but there's actually like hundreds of plants really, in which are also quite varied by like kind of bioregion and kind of peatland type as well. So it's one of the really, I think, quite exciting things about paludiculture is kind of like these plants which we don't typically kind of think of as being kind of used so typically like by humans, I suppose, and kind of thinking of like innovative ways, like as well as like returning to kind of traditional ways of using them. So I'm going to now play a short video from Ralph Temmink, Dr. Ralph Temmink, from who's now at Utrecht University, but has like there's a massive sphagnum farm trial site in North Germany, which is like had a collaboration from those universities in Europe, and there's been some really cool research done on that. So we'll go over to Ralph to hear about some of the cool stuff there.
Hello everybody, my name is Ralph Temmink and I'm assistant professor at Utrecht University in the Netherlands, and I'm happy to briefly introduce paludiculture focusing on sphagnum and nutrient dynamics at the landscape scale. And the work I'm presenting today, I did not do that all by myself, of course, and you can see all the collaborators here and the universities on the right side. So natural peatlands are very effective stores for carbon because of the very anoxic conditions, because of permanent waterlogging by water. And because of this special environment, a very unique biodiversity can be found here. And next to that, peatlands are very good at water retention. However, all these functions are lost typically when you drain and extract peatlands. And one of the environmental problems induced by this is that if you drain peatlands, and which amounts to 0.3% of the land surface, this is responsible for 6% of the anthropogenic greenhouse gas emissions globally. And next to that, peatland drainage results in massive land subsidence and also eutrophication of the surface water. And a way to offset these detrimental effects of peatland drainage is peatland rewetting. And often people say that because of this, there are opposing interests, for instance, between nature and agriculture. But there is, of course, a way that you can unify these two, and that is actually paludiculture. And paludiculture is about wet peatland utilization that preserves the peat body. And here you can see, for instance, reed being harvested in a very wet environment, as you can see here above my face. And depending on the system you can cultivate different species in a paludicultural setting. And today I'm going to discuss a field site in Hankhausen in Germany, which is a 20 hectare site. And here a lot of research is going on about yield, hydrology, biodiversity, fauna, greenhouse gas fluxes, nutrients, fungi, economics, and substrate quality. And in this specific area, they have rewetted a former bog, a bog that has been used as an agricultural site, which now has been rewetted, and where they grow peat mosses, this tiny moss here, which can be used as an alternative to fossil peat for horticulture. And what we did, we looked at the nutrient dynamics at this site, both in time but also spatially. Here we studied what happens in the top layer of the newly formed soil, but also in the deeper soil layer. And this large field site has been established in 2011 here, and in 2016 it has been expanded, and to 2020 again. So the work we've been doing, we did over the last 10 years. So we're going to dive into some results we found. On the y-axis you see the pore water ammonium concentrations, and on the x-axis you see the time since establishment. Well, the 8 and 10 are a bit above my head. In blue you see the site that has been there the longest, and in red is the newer one. So what is striking is that in the top layer, in the top 10 centimeter, no accumulation of ammonium took place. And if we look into the deeper layer, so this is at 100 centimeters depth, you see in the beginning a legacy of ammonium which decreases to almost zero after 6 years. So you really see that the nutrient legacy is declining. Well, I don't have a lot of time, so if you want to know more about the nutrient dynamics of this site, we published already 2 papers, which you can find here and here. And currently, we're also doing some work at this place in a project called Optimos. And here we focus on topsoil removal. So do you need to remove topsoil, or if yes, how much? And that way you can reduce the amount of peat you lose. And we're also focusing on species selection, which species grow best at which conditions. You can see the work going on here. And I want to conclude with this picture here, which shows basically a drained peat soil where carbon and nutrients are emitted, or not emitted, are released, and the land surface is degrading. If you rewet it with suitable water quality, for instance in Hankhausen, which I showed you, what you can gain are, for instance, a very sustainable biomass production on peat soils while reducing carbon emissions and actually sequestering carbon. And with that, I want to conclude my brief introduction about this topic. And I want to thank, of course, the people that were involved with this research, and of course, you, the audience. Thank you.
Yeah, so that was just a bit of a deeper dive into some of the science and of rewetting and paludiculture at that particular site. And so now we'll move to hear from Kate Carver, who is the conservation manager, project manager of the Great Fenn project. So she'll talk a bit more about like the kind of practical kind of conservation side of things, as well as some of the science as well. So we'll listen to her presentation now.
Good evening, my name is Kate Carver and I'm the Great Fenn project manager working for the Wildlife Trust for Bedfordshire, Cambridgeshire and Northamptonshire. I'll do a quick introduction about the Great Fenn, talk in more detail about our Waterworks project, and then mention our most recent project, Peatland Progress. The Great Fenn is situated in Cambridgeshire, with Peterborough to the north and Huntingdon to the south. If you look at the map on the left with a little red spot there, right on the western edge of the East Anglian Fenland Basin. This was a vast wetland, a wetland ecology which has been largely lost since 1600 due to drainage for agriculture. And the situation about 20 years ago was, as we see it on the right hand side, so 2 remnants of that original Fenland ecology concentrated into 2 national nature reserves, Home Fen at the top and Woodwalton Fen at the bottom, separated by intensively drained, intensively farmed arable land, with a resultant loss of Fenland species such as the large copper butterfly, last recorded at Woodwalton Fen in the 1850s. So the solution to this was to create the Great Fenn, which was the UK's first living landscape, conservation on a landscape scale. We have a long-term vision to create a vast new wetland. At its greatest extent it will be 3,700 hectares, a fantastic wetland for wildlife and for people to enjoy in the fens. To date we own half our vision area, and we have 1,700 hectares under conservation management, of which 1,200 hectares is arable reversion, now transitioning to wetland. How we're doing it, it's being delivered through a project partnership comprising the Environment Agency, Huntingdonshire District Council, the Middle Level Commission, who look after the drainage and flood attenuation in this part of the Fens, Natural England and the Wildlife Trust. And really this photograph sums it up. This was a Google Earth satellite flying over from north at the top of the photograph to south, and it got halfway through its flight and then gave up for the day. And so the bottom half shows the landscape as it was, and the top half shows how the landscape looks after we've begun our wetland reversion. And for me, this is the great excitement of the Great Fen. We are pioneers. We're literally changing the face of the earth in our part of the Fens. And having created the wetland, having begun to create that matrix of different wetland habitats, the wildlife moves in. And we know that through our extensive monitoring programme. So previously, when I spoke about the wildlife on the Great Fen, I used to show an artist's impression of Eurasian great cranes, but now I don't need to, because we've got the real thing, as you can see from the picture at the bottom here. And that's just another inspiring shot of the shining waters of some of the restored land you saw in that satellite picture. So that's an area called Kester Stocking. Everything we do is based on science. Some years back we had eco-hydrological modelling done of the Great Fen. So essentially this looked at the water resource available from all sources, from precipitation, groundwater, etc. And looked at the topography and worked out which communities, which plant communities could be created where according to the availability of water. So at the top of the map in the north, that's the lowest lying areas of the Great Fen. The land rises as you come down to the south. So theoretically, given the water and given the ability to control it, we should be able to create the wettest habitats in the north, such as reed bed, open water, wet grassland, fen meadow, and then moving south, the drier habitats as well. So essentially we're working with topography, water and soils. And the soils in question are essentially peat. Here in the Great Fen we still have some areas of deep peat. The map on the left shows the peat depths. The darker the colour, the greater the depth of peat. This was from a survey done in the 1980s. The data did not cover the whole of the Great Fen. And actually we're now in the process of revisiting this. We have Cranfield University working for us, looking at the extent of the peat, the depth, the carbon content, and importantly the amount of peat wastage. I mentioned the Great Fen Project Partnership and how we're delivering the project, and we do have a plan, the Great Fen Master Plan, which you can download from our website, which sets out 4 aims for the project. Creating that wetland habitat is one of our aims. And another of our aims is to plan, design and manage the Great Fen to benefit climate change adaptation and mitigation. And we do that in 3 main ways. So firstly, through creating that connectivity so that terrestrial species have corridors of movement to move between our new habitats. We know that with climate change, species are altering their geographical range, such as this willow emerald damselfly. But for the terrestrial species, we need to create corridors of movement. As you can see from the map, we're beginning to get that connectivity in the north of our project. And when I talk later on about our Peatland Progress project, you'll be able to see how we're also achieving it in the south, so we get connectivity all the way through. The second way in which we can help with climate change is through flood attenuation, through providing, well, really through making the landscape more resilient to absorbing excess water. At the moment, Woodwalton Fen is used as an emergency floodwater storage area for the middle level. When they have too much water in the system, water is allowed into Woodwalton Fen. And that can happen at any time of the year. It's particularly damaging in the summer if there are nesting birds. And one of the aims of the Great Fen is to find alternative water storage areas within a landscape that can absorb that additional capacity. And then the third way in which we're helping with climate change is through carbon, really preventing the release of carbon dioxide. As you know, when peat dries out, it oxidizes, peat is physically lost, it blows away, and more importantly, perhaps, it emits carbon dioxide. So that brings me to our Waterworks project. This is a picture of a fen blow. So this is where the top few centimetres of peat have dried. They've become very dry, very friable. They're releasing carbon dioxide, they're blowing away, and we get these black fogs in the fens. A lot of peat is lost each year in the fens. Not only that, but it pollutes the watercourses, and of course it emits carbon dioxide. We're not the only ones who are concerned about this problem. Farmers and the NFU are very concerned as well. They have a goal of achieving net zero by 2040. So working together, we need to find solutions to these problems. And one of the solutions that we've been pursuing is our Waterworks project. In 2019, we were able to win funding from the People's Postcode Lottery for our project Waterworks, which is all about developing more sustainable systems. There are two elements of it: to develop a more sustainable farming system, trialling crops that grow in wet conditions, wet farming, and also transforming how people work together for sustainable development in the fens by achieving a UNESCO biosphere designation for the fens. We have project partners to help us deliver all this: Cambridgeshire Acre, who are working on the biosphere aspect, and on the wet farming we have UK Centre for Ecology and Hydrology, world leaders in climate change science, and University of East London, who are experts in wet farming, also known as paludiculture, the methodology and the crops. And the link between the two elements of our project, the wet farming and the biosphere, is the peat, because the peat largely defines the extent of a future biosphere designation. We're all facing the same problems in the fens: how we sustain both agriculture and the natural environment, how we manage the water resources, how we protect the peat soils, how we allow for development and support rural and urban livelihoods, and how we tackle climate change. Our project looks at all of these things. So what are we doing exactly? We know that wet farming can help build soils, prevent the loss of peat. We know it can clean water. We know it can lock in carbon dioxide. And what we're doing is conducting, for the first time in the UK, field-scale trials of wet farming paludicultural crops that have applications for food, industry and biomedical uses. And we're doing this in real-life conditions in a fen farm within the Great Fen. So previously there's been small-scale academic trials of paludicultural crops, but we're doing it in a farm setting on a larger scale. So this is our wet farming site. It's a 5-hectare site within the northern part of the Great Fen, and it consists of a series of 10 paludicultural beds which are surrounded by a bund, a raised bank. So the top 15 centimetres or so of peat was taken off the surface, which was levelled. A deep trench was dug all around the site. The peat that was taken off was then compacted into the trench to create an impermeable bund. There's a bund between each bed, so they're all separate, but they're all linked by a system of pipes which moves water through the site from the north in the top to the south at the bottom, feeding the paludicultural crops as we go. And the crops themselves help to clean water so that we have the crops that require the cleanest water at the bottom. So starting at the top, we have 2 beds of reed mace, Typha. We have 2 beds of reed, Phragmite australis. We have a bed of Glyceria fluitans, which is a cereal crop which we're trialling, so for the first time on a field scale in the UK. We have 2 beds of what we're calling our novel crops, so these are Fenn species which have applications for food, flavouring, biomedical use. And at the bottom we have 3 beds of our sphagnum. We also have a water storage reservoir. So this was the site upon we'd largely finished completion of the infrastructure works back in July. As you can imagine, COVID has been a massive disrupting factor. But by 2020 we were wetting up the site, so charging the system, bringing the water into the top bed, which then runs through these connecting pipes down through all the other beds. I'm feeling very jolly about it, as you can see from the picture in the centre of my colleague Mark. And then we started planting. Yes, we're doing it all by hand, which is not how a Fenn farmer would do it, we know that. But for us, this helps us with another aspect of the project, which is community engagement and giving people an opportunity to take positive physical action against climate change. So we're doing the planting with a lot of volunteer help, volunteer groups, staff groups, including some notable planters such as Tony Juniper here at the bottom on the right. And by November 2020 we'd got 6.5 beds out of our 10 planted, so about 3 hectares planted by hand, which was about 50,000 plants. And the sphagnum planting is to follow. We have 150,000 sphagnum propagules to put in between this autumn and next spring. And yeah, that's it. The sphagnum is now going in. We are using the services of a company called Micro Propagation Services Limited, who have propagated the sphagnum for us. This particular sphagnum is coming in the form of little hummocks with individual strands, which are then very carefully placed into the peat. You see it's a clean bed there. We have to have a clean, weed-free bed where possible. We've developed some technology of our own, including the Wander dibber on the left-hand side, which makes little depressions all correctly spaced, ready for the sphagnum to go in. And we're also trialling a new form of plant husbandry here with some spray-on sphagnum. So essentially it's strands of sphagnum suspended in a nutrient fluid. So it'll be interesting to see how that works. Just returning to the crops themselves, what are they useful for? Well, first of all, the Typha. The root itself the tuber is very sweet, and it can be used for cattle feed and human feed. In fact, if you look on the internet you can find recipes. The body of the plant can be dried and used as biomass for fuel, for heating. It can also be compacted into an insulating material used in building insulation. And it can also be used for things like food packaging. So wouldn't it be great if in the future all those plastic food containers disappeared and we had Typha ones instead. The Phragmites, again, that can be used as a biofuel, compressed into briquettes. It can be compressed into a building material. It can even be blown into cavity walling for insulation. Glyceria fluitans is our food crop, also known as sweetgrass or manna grass. It was harvested from the wild in medieval Europe, and we can see there might be an application for it as a niche cereal. So think of porridge or muesli. So it can be used as a whole grain or it can be milled. East Anglia is the breadbasket of the UK, so we were keen to trial a food crop, hence this one. But the star of the show is really the sphagnum moss, the wonder crop. Perhaps most excitingly, it has huge potential as a horticultural growing medium. At the moment, when you buy compost from a plant centre, it is comprised of sphagnum moss, and probably that has come from a virgin peat bog somewhere in Indonesia or Canada or even Ireland. So there's that whole domestic market, but also in the Fens, this is where all the vegetables and salads are grown that you buy in the supermarket. They're all grown in little peat plugs. And wouldn't it be great if those big producers could call upon local farmers who are producing sphagnum as a crop, which they could then use as growing medium. It has lots of other properties as well. It's very absorbent. And in the 1970s, Johnson & Johnson took out patents for use of sphagnum as an absorbent in sanitary products, things like nappies, sanitary towels, etc. It's naturally antimicrobial, and it can even be used as an air purifier. I'll return to that. So within about 10 months, our little sphagnum propagule should have grown into a closed canopy. And the idea is that you leave it growing, you just harvest however many centimetres you want off the top, and the rest will keep growing.
Ian, so I'm gonna stop the presentation there, and if you want to watch the rest of it, it is on our YouTube channel, along with it's as part of a webinar we did last month on peatlands and agriculture in the UK, where we also talked to the chair of the Lowland Peat Agricultural Task Force, which is a government task force looking at sustainable management of peatlands, which have historically been used for agriculture in the UK. But yeah, I think from Kate's presentation and Ralph's, you really get a, I think that one of the messages that comes through is this, you really need a landscape approach, a landscape perspective on paludiculture. So Ralph and his colleagues' research suggests that, you know, the sequestering nutrients left over as a legacy from historic fertilizer use in the drained peatland, you can actually reduce pollution downstream at sites beyond the paludiculture site. You know, other research at that same pilot site in Germany actually found there's like quite high biodiversity value of invertebrates, and particular kind of peatland specialist spiders, which is quite cool at this site. And that was even like kind of in the first year, you know, when it's actually mostly bare ground. When you've just planted the sphagnum, they found like an increase in invertebrates which are kind of specialized to that kind of early successional pioneer kind of habitat. And so in that way you can provide a refuge for peatland species in the landscape, and I think Kate kind of really touched on that as well. You know, how this kind of farming approach is integrated into a kind of a wider conservation landscape approach, you know, which involves full restoration of peatlands, as well as situating that within an agricultural matrix and stuff. So, and all the challenges and opportunities that come with that. And it's also inherently basically has the landscape in mind, because the whole point really of paludiculture is having a farming site that is more attuned to the land it finds itself in. So rather than drain a peatland to grow dryland crops in a wet landscape, you re-wet the peatland and cultivate peatland species. And so what that means is, depending on what the peatland is and where it's found, you're restoring, you might have different plants in mind, as we've kind of discussed. So one thing is about the hydrology of the peatland. Is it getting most of its water from rain, or from groundwater sources, or anthropogenic kind of canals and things like that in the, as I said, in the agricultural kind of landscape. And that kind of will all determine kind of how it ends up being. and then also in different areas of the world, paludiculture will look different as well. So in North America, there's several plant species that can be cultivated which have like particular importance to First Nations and Indigenous peoples there, and that might include as well wild rice cultivation in an ecosystem that you're also cultivating fish in lakes and things, and peatlands that might be adjacent to lakes. And then as well in Southeast Asia, which hold vast amounts of peat, and a lot of which is threatened by oil palm plantations. You know, there's a whole other kind of set of tropical tree species and fruit species, and as well as grasses which you can use for construction materials. So there's a kind of, you have to have this landscape specific, context specific approach to it, which I think is really a strength of paludiculture rather than a weakness, but I think it's something that needs to be considered and stuff. And as Kate said, kind of getting local people involved in the planting and this kind of connection to communities around the peatlands as well is key. And so I just to kind of begin wrapping up, we've kind of scratched the surface, and really there's loads more we actually just don't yet know about paludiculture, which I think is really exciting. So potential plants and best practices are still being researched and trialed, and policies are still being drafted and challenged. And so one key thing I'm quite interested in is how resilient will peatlands be against climate change? So will they continue to be carbon stores, and how can paludicultural practices be designed to ensure that they continue to be carbon stores rather than emitters as they are now, and what we're trying to kind of solve with paludiculture and rewetting. And then finally, a repeated question we've also been asking ourselves is really, and one I want to kind of leave you with now, and I think which we can maybe discuss on the Hoover platform, is how should paludiculture fit into an anti-capitalist, anti-colonial, agro-ecological movement? And as Bethany said at the start, we're not experts. Our method at RE-PEAT is to really just get people excited, bring people together, ask questions, and then and bring people from different projects and disciplines, and then kind of co-create and explore some suggestions of ways forward together. So I know people always say it's the end of talks, but we do really genuinely want to hear from you, and I'm seeing loads of questions and everything in the chat, which we just don't have time to go to, and it's awesome. And I would really encourage people to bring that discussion onto the platform. We can just continue talking, and yeah, we'd love to hear from you and for you to get in touch through our through the platform, as well as email and our social medias and stuff. And we'll be posting some kind of questions for pondering and discussion as well there, and this is, as we said, this is the beginning of something, hopefully, and it's just thrilling to see so many people here, so thank you so much for having us. And Bethany, I don't know if you wanted to add anything.
Yes, that I was trying to monitor the chat and then try and give informed answers, and it's quite hard to do that in real time when there's other questions coming through. So yeah, please, we'll answer them the best we can on the Hoover platform afterwards. There are some other people who are very knowledgeable about paludiculture as well in the session that I know, who are also super interested in it, so also just interact with one another and stuff like that. That's really great as well, to kind of build a little bit of a paludi community. Thanks, everyone.
Brilliant. Thanks so much, everyone.